Hey everyone, welcome to Code Harmony. Today we are going to solve this LeetCode challenge 2683, neighboring bitwise XOR. It's based out of bit manipulation. Let's try to understand the problem statement with the help of an example. Here what is given to us? A derived array. This array is given to us and it's a binary array consisting of only 0 and 1. And they are saying that they have derived this array from some kind of original array using this expression. How? Ith item in the derived array is the XOR of ith item and I plus 1th item from the original array. Let's say original array is something like this. 3 elements are there and the indices are, let's say 0, 1, 2. So in this case, this 1 is the XOR of 0th item and 1th item. And this second item in the derived array is the XOR of 1th item and 2nd item. Now what about the 3rd item? In case of 3rd item, we are taking XOR of 2nd item and then 0 item. We are taking or considering item in a circular fashion. So yeah, this is the problem statement. Given a derived array of length and size, and it is derived by computing the bitwise XOR of adjacent values in binary array original from 0 to n minus 1. Derived I is the original I, XOR of original I plus 1. And there is one special case for the last item, original I plus original 0, because there is no original I plus 1. Okay, so this is our problem statement. Derive is given to us. This original array we have to find. And we don't have to return the original array. We just have to return whether there is a valid possibility of original array or not. So before moving ahead, let me tell you some things about the XOR operation. First of all, what is a XOR operation? If two values are same, then I'm getting 0. So 0, 0, 0, 1, 1, 0. And if two values are opposite, 0, 1 or 1, 0, in that case is I'm getting 1. So this is my XOR operation. And there are a couple of properties associated with the XOR operation. First is commutative. And what is commutative? If let's say I'm taking A XOR B, then it will be equivalent to B XOR A. What about associative? Let's say if I'm taking XOR of B and C and then taking XOR with A, it is also equal to the, if I'm taking XOR of A and B, then I'm taking XOR with C. And what about identity? Identity of property is something, let's say for plus operation. What is identity? Identity is 0. If A plus 0 is giving A, similar value. So identity is something, if I'm doing applying the operator with some value, I'm getting the same value. So in case of identity, for the XOR operation also, we have 0 as identity. If A XOR 0, so what value I will get? I will get A. So this is my identity. And what is self-inverse? Self-inverse is something I am taking the XOR operation with something, I am getting 0. So in this case, what is the self-inverse? If we are taking XOR with the same value, I am getting 0. Because for same items, I am getting 0. And for different items, I get 1. So if AA is 0, let's say 1 0 1 0, XOR 1 0 1 0, all are same, I will be getting 0. Now there is one more property, inversion. What is inversion? Let's say A XOR B is equal to C. And this is a valid expression. Now, if this is a valid, then these expression will also be valid. If I am taking B XOR C, or B will be equal to A XOR C. If the first expression is valid, these two expressions will also be valid. So this is my inversion property. Let me take a proof of this inversion property, because this is going to be useful in this example. Let's say I'm taking 3 variables. Let's say A is 1 0 1 0, which is 10. B is 1 0 0 0, which is 8. C is, what is the C? If I'm taking 1010 XOR 1000, that is A XOR B. I want to find the C. What will be C here? Same 0, different 1, same. So it will be this. And what is this value? This is 2. B is 8 and A is 10. Now A XOR B equal to C. Now let's see whether A is equal to B XOR C. What is the value of A? 1010. What is the value of B? 1000. And what is C? 0010. Now let's evaluate this B XOR C. Same, then 0, opposite, then 1, same, then 0, opposite, then 1. I am getting 10. So A is also 10. So here A XOR B is equal to C. This expression we took, and what we analyze is B XOR C is also true. Now what about B equal to A XOR C? What is the value of B? B is 1000. 1000. A is 10. 1010. And what is C? 0010. Let's evaluate this expression. Same, and only 1 is different. So it will be 1000, which is same as B, that is 8. So if this expression was true, then these two expressions are also true. This property is called inversion. And we are going to utilize the same property in our example. Let's come to the problem statement. Here, this derived array is formed using this expression. Derived I is equal to original I and original I plus 1. And we have to find the original array. One thing is there, both of these array are going to be the binary array. First one is derived. Derived is the binary array, and we are sure that original will also be the binary array because it's a binary operator 1010. Okay, so original I have to find. Derived is given to me. This is not given. This is not given. So let's apply the inversion property. What is inversion property? I want to find the original array. Let's say this I want to find. Original I plus 1 is equal to derived of I XOR original of I. This is the same thing. This is derived of I is equal to original of I XOR original of I plus 1. So I can find original of I plus 1 is equal to derived I original I. See, just try to see that this derived I is given to us. This is the first element in the derived array. And what about original of I? Is this given to us? No. But we are sure that as it is a binary array, so how many possibilities are there? This can either be 0 or 1. As there are only two possibilities, why don't we just form two original array? So let's say one original array I'm going to start with 0, second original array I'm going to start with 1. And this is original I plus 1. Using this expression of original I plus 1 is going to be equal to derived of I plus, not plus, it is XOR, original of I. Use this expression and try to fill your original array. Firstly, just consider your starting item in the original array is 0, then your starting item in the original array is 1. Let's try to see. Let's try to form the original array. Given array is 1 1 0. This is my derived array, and this original array I need to find. See, in this case I am seeing I plus 1. So if it is I plus 1 and I want 3 element in the original array, let's keep it like this, 3 element. and from here I'm going to start. What about the ith item? Ith item, I have two possibilities, either 0 or 1. Let's say I am considering the first possibility right now, which is 0. Let's say I have assumed that my original 0 is 0. Now what is the value of this index? So indices are 0, 1, 2, 3. What is original of 1? Original of 1 is equal to derived of 0, original of 0, OR of these two values. If I take OR of these two values, 1, 0, these are opposite, I am going to get 1. What about original of 2? Derived of 1, original of 1. Okay, similar elements are there. Similar means 0. Now what is this 3 element? See, in this case, in the problem statement, we are told that for the last item in which is original of n minus 1, what we are doing is we are taking XOR of original of n minus 1 or original of 0. We are doing the cyclic stuff. But in this case, we don't want to go cyclic. Just write it here as well. So what is that value? Original of 3 is equal to derived of 2, original of 2 XOR. 0, 0 means 0. Now we have our original array, and if you want to validate, you can validate whether this first two element are returning as a XOR of this value. 0, 1 is 1, 1, 0 is 1, and 0, 0 is 0. Okay, but now actually in the original case, we want only 3 elements in the original array. What those 3 elements are? These 3. And this item, instead of this item, I should use the first one. If instead of this last item, I have to use first one, in that case, these 2 items should be same. So I can just check one condition, that in my original array, if the last item is equal to the first item, it means that this original array is valid. Otherwise, let's say if in the last item I'm getting 1, it is not valid. Okay, so this is something we have to do. Let's check the another case. You'll get more understanding. What is derived array? 1, 1, 0. And what is the original array I need to get? This one. Not just 3. I need 4 spaces in this case, because I don't want to add a cyclic check. Okay. Initially in the first attempt, we started with 0. Now we will check the second possibility, that is start with 1. So if we have to start with 1, I will be writing 1 here, and I have my expression original of I plus 1 is equal to derived of I, original of I. Now these two values I'm going to have at every iteration. Let me mark the indices 0, 1, 2, 3. Now what is the value of original of 1? Original of 1 is equal to original 0 XOR derived 0. 1, 1, both are same, it will be 0. Now at 2, these are opposite, 1 and 0 are opposite, I will be getting 1. At 3, 0, 1 is opposite, I will be getting 1. Now in this case, the first and the last item is also same, and this original array we have derived from our formula, so it means it is a valid one. So either we start from 0 or either we start from 1, I am getting a valid original array. So you can just maintain a flag. Just derive the original array and see whether the first element and the last element is matching. So that is a flag. If it is true, the flag is true. If it is false, flag is false. Similar to this case, the flag will be either true or false. Now, what your answer is? The flag starting with 0 or flag starting with 1. Any one of these two flags should be true. This is my answer. So using this formula, we have created our original array, and in our original array, we are checking whether the first element is the last element is same, then my flag is true. And we have only two possibilities. Either the original array is going to start from 0 or the original array is going to start from 1. If any one of this original array is giving me the right answer, then just return true. Now what is the time and space complexity of our approach? Let me check the constraints. The length will go till 10 to the power 5 and all the values are 0 or 1 in the derived array. So original array is also 0 and 1. And in this case what we have done is we are just capturing the original array using the derived array using a formula in a single iteration. So I am seeing that it's a linear operation. So if it is linear operation, the time complexity will be order of n. What about the space complexity? Space complexity will also be order of n because we are utilizing extra space to capture my original array. So this is the time and space complexity. Now we'll code this approach. Let's capture the length of this derived array. Derived dot length. Now the original array, I'm taking it for the size n plus 1. New int n plus 1. Now we have two possibilities, whether the original array is starting with 0. If it is starting with 0, for every item in derived array, I equal to 0, I less than n, I plus plus. For every item in derived array, the original array I plus 1. What is that? Derived of I XOR original of I. We are taking care of the cyclic stuff, that derived I is original I plus original 0 for n minus 1. What I'm doing is I'm keeping it one size extra. So in this case, if the last item in the original array, that is nth item, and the 0th item is same, it means that this array is valid. Now let's capture the flag boolean valid. If I'm starting with 0 is equal to original of 0 is equal to original of n. If this is the case, I'm getting a valid answer if I start with 0. In the end, if I just do the valid 0, now there is one more possibility left where original array is starting with 1. If it is starting with 1, then let's capture it another flag. Rest will remain same. Okay. Now in the end, if any one value is valid 0 or valid 1, I am getting the right answer. And we just have to return a boolean value, whether we are able to form any kind of original array or not. Now that's all we have to do, and also let's rename this derived to D. Okay, let's run our sample test cases. Sample test cases are passed. I'm submitting the problem. It got submitted successfully. I hope you understood the approach. Thank you guys. Bye bye.